So we got one more assignment, guys, 424, and then we're done. Effects of change. Ooh, they're giving us some star connections, right? Let's exit out of these guys. 14, 17, 19, and 24. Okay, so just start from the top, right? And then we even got these hints right here for us. Okay, let's see, 14. This is a long one, guys. So students at a school will sell hats to raise money. There's some hats left over from the last year, and 20 boxes of hats will be ordered this year. When the order arrives, the total number of hats the students will have can be determined using the function f of x or y equals 48x plus 37, where x represents the number of boxes ordered. If the number of hats per box changes so that the situation is modeled by the function hx equals 24x plus 37, then how many fewer hats will the students have available to sell if they still order 20 boxes? So how did I figure that out? I have no idea. But look at our hints, right? It says both, right here it says graph both equations given in the problem on desmos.com. And so what equations did they give us, right? Let's exit out. 48x plus 37. So remember, f of x is y, so y equals 48x plus 37. And they also gave us h of x equals 24x plus 37. We'll type that in as well, right? We got both functions. Okay, now what? Then graph the equation x equals 20 and record how many units lower the second equation is at x equals 20 compared to the first. Okay, so put x equals 20 in here. This way we can kind of see where it's at. Because remember, the problem says we still order 20 boxes. And it says x represents the number of boxes ordered, right? So let's go to 20 and see where these guys match up at, right? So right away you see the green line is going to get there faster, right? So right here, it looks like we're locked up at 517. So that's how many boxes the second equation gets, 517. And we go up 997, right? So what's the difference between how many more boxes does the first equation have in the second? Well, it's going to be these two values, right? 997 minus 517, right? 997. And this is actually a calculator too, you'll see right here. What's that number right there going to be, right? Let's look, 997. Because we look closely, that's where they match up, right? And we look closely right here, 517 is where these match up, right? And if you zoom out, your graph will kind of show you, right? 997, 517, you subtract them, you get this number. I think that's going to be your answer. Okay, move on to 17. The slope and y-intercept of the graph of f were changed to make the graph of g as shown below. Okay, so which statement describes the changes that were made to the graph of f to make the graph of g? Okay, this one is a little difficult, guys, but just bear with me. There's a way we can do this that it'll be a lot easier, all right? So right away, let's look at our y-intercepts, right? Remember, what's our y-intercept, right? In the problem, it's going to be whatever's on this straight line in the middle, right? That's called our y-axis. See the y at the top? There's a line right here, right? So we see f, y-intercept is right here. That's a y-intercept at 3, right? And this one is at -2, right? So how many units am I changing here? I go down 1, 2, 3, 4, 5, right? So I go 2, 1, 0, -1, -2. That's 5, right? I'm going 5 down, right? So right away, in order for f to become g, y-intercept was decreased by 5, okay? Half these answers say increased by 5, right? So right away, b and d, we can just get rid of those, right? Because they can't be it. Because remember, f, this y-intercept is not going up because, see, this one's going down, right? So now we got either the slope was multiplied by 2 or the slope was multiplied by -2, right? So I want you to notice something about these slopes, right? See how this line's going this way and this line's going this way? They're kind of going different directions, aren't they? Right? Remember, if you multiply your slope, this is slide 6, the original slope by a negative, the graph will flip to the other side of the graph, facing different directions, okay? So only one of the answers that is possible could be right, left, has multiplied by a negative, right? C multiplied by -2. And as you can see, these guys are different directions, right? If the graph was multiplied by just +2, then F and G would be facing the same directions, as in they'd be kind of going this way down, right? So the slope has to be multiplied by negative. So I think it's got to be, it can't be A, and then we eliminated B and D because of it's saying our y-intercept was increasing when it has to be decreasing according to, it's going down, right? And that means decreasing. Okay, 19. The graph of y equals 3x squared minus 2 is shown below. If the coefficient of x squared is changed from 3 to another positive number to create a new function, how will the graph of the new function compare with the graph of the original function? They give us a lot of options here, right? But let's just go to our slides, right? Because you can figure out a lot if you just look at our slides and figure out, what are they actually asking us here, right? And what we could also do is graph it and just get a phantom number. I think it's my hint is what it said, right? Coefficients are the numbers attached to x squared in the problem, right? So they ask us what coefficients are. So 3x squared, so 3 is our coefficient here because it's attached to the x squared, multiplied by it, right? So it says change to another positive number, right? So let's say I change it to 2, right? Let's graph the first one out. Y equals 3x squared minus 2. Change to y equals 2x squared minus 2, right? And let's zoom back in because I think I kind of got it. So what do we see here, right, compared to these two graphs? So one of them kind of goes out further than the other one. One's kind of further inside, right? The x-intercepts in the new graph will be the same. Well, no, because those are different numbers. Vertexes of the new graph will be different from the vertex of the original. Well, no, they look like they're the same. New graph will be wider or narrower than the original. Well, they don't look like they have the same wideness or narrowness, that's for sure. New graph will open in an opposite direction. No, they're opening the same direction. So I don't know. What do you guys think? Okay, last problem. So there's a lot of noise, right? Airplane's altitude in feet. During its descent for landing can be found using the function f of x equals -300x plus 30,000, right? X represents the horizontal distance in miles from where the plane begins its descent. So remember this part. It's very important. So after new government regulations become law, the airplane's descent will be modeled by the function g of x equals -300x, same exact slope, right? Plus 30,500, so a little bit higher. Which statement describes this change, right? So think to yourself, what changed here, right? The y-intercept, right? And that's in our hint. There's a change in the y-intercept, right? Because look, it changes, because remember, that's the number by itself, 30,000 to 30,500, right? So think about when the graph would be 30,000, right? When x is 0, because -300 times 0 is just 0 plus the 30,000, right? Because remember, x represents the horizontal distance in miles from where the plane begins its descent, right? So wherever 30,000 is, 30,500, that's where we begin our descent, right, in feet. So look at these last two options. The airplane descends 500 feet per horizontal mile faster or slower. Well, that might be true if we were talking about a change in our slope, right? But we just said our y-intercept is the thing that changed, not our slope. So it can't be h or g, right? So then it says the airplane starts its descent from an altitude either 500 feet higher or lower. So again, this has a higher number. 30,500 is 500 more than 30,000. So you tell me, is that an altitude higher or lower? Because if it's a higher number, I think it's probably a higher altitude as well. So I think we can get that one as well. All right, guys. Hopefully this was helpful. I'm going to be uploading this today.